Hello, everyone. My name is Andrea, and I will be talking to you about cholera. So, The Outbreak Cholera by Andrea Zavaleta-Vega. Now, what is cholera exactly? Its genus species is Vibrio cholerae, and although there are many hallmarks to this disease, the main ones are watery diarrhea, dehydration, and abrupt onset cramps. And these cramps can be leg cramps or stomach cramps or any cramps of the sort. Now, how does cholera work? There aren't defined methods of how cholera truly works, but there is supposed multiple adherence mechanisms for it to work. And this is because cholera is a disease of the small intestine, and it has to get through the pH of the intestinal tract to be able to infect the body. So there are thought to be multiple adherence mechanisms. One of these is hemagglutinin, which is the clumping of red blood cells, and toxin co-regulated pili, which brings the bacteria together, and because they're all together and releasing a toxin, it makes it more concentrated and more harmful to the body. Now, cholera has high motility, and this is important because it needs to be able to get through the mucus layers of the intestine to be able to get to the cells and to infect the body. Now, cholera works as an AB toxin. So, region A of the toxin starts the activity of CT, which is the cholera toxin. And region B binds CT, or the cholera toxin, to the host membrane via cell receptors. And it works through a signal pathway which will permanently activate the G protein. And because of this permanent activation, it causes the transport of water and electrolytes out of the body, unregulated, which is what causes the diarrhea and the dehydration. Now, how does one acquire cholera? The main method is ingestion of water and food with contaminated feces of an infected individual. Mostly it's seen through contaminated water. The impact of cholera. It is an indicator of inequity and lack of social development. So it is seen in places that aren't fully developed or third world countries, places like that. And this is an entirely treatable disease, and it can be treated or prevented mostly through clean water, proper sanitation, health, education, and the proper handling of food. You can see how it's clean water because if it's a waterborne disease and you have clean water, then you can't get it. Also, proper sanitation of washing your hands before handling food, and just knowing how disease transmission works is really helpful in preventing this disease. Also, there's the oral cholera vaccine, or OCV, and it is given in 2 doses. The time period between these doses depends on which one of the 3 vaccines that you get, and it provides protection for 2 to 3 years, also depending on which vaccine. But there is research development in killed and active and conjugated vaccines for more permanent protection against this disease. History. This was in London at this time, and so there was a major industrialization and major factory work between the 18th and 19th centuries. And because this mass industrialization, they needed people for the jobs in the factories, so there's a lot of population migration from country to the city. And because of this mass migration, they needed to live somewhere, and London wasn't prepared to house this many people. And so there was poor housing and just overcrowding in general in the area. And there was, because of this poor housing and overcrowding, there was inadequate waste disposal systems. So they were throwing their feces and things like that into the Thames River, which is not great because that is also where they got their drinking water. Also, during this time, the area of the Thames River was known as the Great Stink because of how bad the river smelled and how it leaked into everywhere else. Now, who was John Snow? John Snow was really vital during this outbreak. He was born in 1813 and died in 1858. He was a medical apprentice at 14, and he was considered to be one of the founding fathers of epidemiology. And during this time, he was experimenting with anesthesia, and he was able to develop an anesthesia practice in his lifetime. So he was really making some advances in medicine at this time. 1854, London. This was the major outbreak of cholera in London, and you can see how John Snow, he mapped out the locations of cholera deaths, because on the map, every single line is the death of someone infected by cholera. And you see right around the Broad Street pump in the middle, there's a great cluster of deaths. And this is really important because the disease was thought to be an airborne disease, but because of the amount of clusters surrounding this water pump, it led him to believe that the Broad Street pump was contaminated and what was causing this outbreak. Now, there were outliers to this outbreak, and one of them was the brewery. It was surrounded by cases, but not many people got sick, and if at all. And this was because they had their own water supply, which would have them not going to the Broad Street pump to get water. Also, there was bottomless beer for the workers of this brewery, so it was thought that they didn't even drink water when they were at work, so they wouldn't have any need to go to the pump. Also, there was Poland Street. It was also surrounded by cases, and it had its own water supply, again, showing that the pump was contaminated and that they wouldn't need to go to the pump if they had their own water supply. Now, there was a woman who specifically went to the Broad Street pump because she liked the taste of that pump. And so even though she didn't live near the pump, she traveled all the way to get water from this specific pump, and she died from cholera. Now, the cause, the Broad Street pump was polluted by sewage, as you can see by the waste disposal into the Thames, and it was contaminated by baby diaper or feces. John Snow was able to convince the authorities who were skeptical about his conclusion about the pump, so he was able to convince them to remove the handle, and the cases rapidly declined from there. And you can see the pump on Broad Street. Now, the effects of cholera in 1854, well, there's a decent amount of deaths by this outbreak. Between August and September, there were 600 deaths in 10 days, and these were caused by the pump specifically, so in Broad Street, there were about 600 deaths. Between September and October, there was 1,263 deaths in 7 weeks, and this was due to the Southwark and Vauxhall water companies, and these have been contaminated by the Thames River. But these occurred a little bit later than the Broad Street pump, so they were able to figure out how to stop it. There were many social effects to cholera, and one of these was that John Snow was able to prove that it was a waterborne transmission of cholera, and this was great. First of all, because people thought it was airborne, and with all the great stink and everything, if it was airborne, it would have been a really bad outbreak at this time. But since it was waterborne, and 30 years earlier, they had figured out how to deal with a waterborne disease. So after knowing that it was waterborne, they were able to take care of it. It also established basic methodology of modern public health when it comes to infectious disease. And you can see this when Jon Snow is mapping out the deaths and trying to find the source, because knowing the source is really vital in knowing how to deal with the infectious disease. Jon Snow also provided validity to the germ theory, which many professionals at the time were very skeptical of, but through his mapping and establishing this methodology, he was able to add validity to the germ theory. Because of the effects of cholera and seeing that it was a waterborne transmission, it documented the first use of chlorine as a disinfectant in London in 1897. And this was really vital because clean water is a very good way of avoiding cholera. And using chlorine as a disinfectant later trickled down into the US and other places in the early 1900s. Cholera advancing epidemiology. So you can see how Jon Snow, obviously he determined the mode of transmission. Robert Koch, which we have learned about, he was internationally recognized for growing and identifying cholera in 1883, but he was also very important in discovering anthrax in 1880 and tuberculosis in 1882. He was said to be a leader in defining criteria for infectious agents, which you can see with how many discoveries he's made for infectious agents. And he won a Nobel Prize in Medicine in 1905. Now, Filippo Pacini, he was recognized for the discovery of cholera in 1984, which was formerly known as Vibrio cholerae Pacini 1854, but now it's just known as Vibrio cholerae. And that is my works cited.